A car traveling at 24 meters per second skids to a stop in 2.55 seconds. Determine the skidding distance of the car, and let's assume uniform acceleration. So we know that our velocity initial equals 22.4 meters per second. And we know that the amount of time it takes to skid to a stop is 2.55 seconds. And the fact that it is at a stop means that our velocity final equals 0 meters per second. So velocity initial equals 22.4 meters per second. Velocity final equals 0. And our time equals 2.55 seconds. The thing we want to know is displacement in the x, because it asks for a distance. In order to do this, I'm going to use the velocity initial plus velocity final, that quantity, divided by 2, that's average velocity, equals distance divided by time. So velocity initial is 22.4 minus velocity final, which is 0, that quantity all divided by 2, and that equals distance divided by 2.55 seconds, or displacement divided by 2.5. So any number minus 0 is that number again, so it's 22.4 divided by 2 equals displacement divided by 2.55. When I do the math, 22.4 divided by 2 gives me 11.2 equals displacement in the x divided by 2.55. In order to get displacement all by itself, I'm going to do the opposite, so I'm going to multiply by 2.55, and I do that so that the numbers cancel. But whatever I do to the right, I have to do to the left as well. 2.55. And when I do the math, I see that displacement in the x equals 28.56 meters. But now we go back and we take a look at significant figures. This has 3 sig figs. This doesn't count. This has 3 sig figs. So my answer is going to have 3 sig figs. And when I apply significant figures, I get 28.6 meters.